good data, we scraped it, we cleaned it, and we do not source this from multi-sources ingestion or stored the data. We synthesize the context. And I think that vocabulary has more to do with preparing the data to give it, to hand it off to an agent. And then we serve the data via the dashboard and the agent that queries the statistics. This is a pretty funny tweet I thought from the Perplexity CEO. He did this roughly a year ago. He said, testing a new cron job. Nice thing is you can call it an AI agent now in 2025. So, cron versus agents. Cron by nature is scheduled. It's going to run a set of instructions at a specific time. So it's more deterministic. That differs from agents, which are, you guessed it, non-deterministic. They're more autonomous, and I hope that they reason through a goal and they decide what tool to run. Resilience-wise, cron is more brittle. If the HTML or the DOM changes, oops. However, the agent, I would presume, would be self-healing. They would be able to iterate and get better and fix it. Cost, cron is negligible. It's just like standard server costs versus the agent, more variable. You have LLM tokens in inference compute. My 2026 prediction, agent harnesses will replace benchmarks. Right now, I think we've been seeing benchmarks are a lot more saturated. There's less of a distinction between a great model and a good model. So a solution to that would be to have agents run more complex, multi-day tasks, often in an agent harness. So that's kind of like robust infra around the LLM or the agent that optimizes for long-running tasks and provides memory, evals. You can have human in the loop. Structure of the context. And DigitalOcean droplets and cron jobs are a perfect harness playground for testing your agents. What's next? I would like to make this demo multimodal, have some video analysis, run cloud code on a GPU droplet, so I can go to sleep and it's still running, kind of like this cron job. Some resources, cloud code on droplets, set up server environment with cloud code on droplets, speed up stable diffusion on GPU droplet, on GPU droplets here. I will give you the QR code, as well as DigitalOcean is hosting quite a few AI meetups this coming year. We're partnering with Workato and Anthropic for an upcoming agentic healthcare night, as well as Jeff Lawson's new Founders Garage, TQ Ventures, for agentic AI night. And I'll be showing the QR code with the GitHub repo, the GitHub agenda that I just went through with all the resources, and this link. You can contact me. That QR code has some links to my socials and my email. And I will be bouncing to Sacramento or a tennis tournament now because traffic is getting. Thank you.
I think next we're going to have Sarah, but in the meantime, you can obviously take questions if anyone has DigitalOcean questions and WMDA questions, tennis questions. She's very good at tennis. Yeah, Sarah.
Yeah. Wait, sorry, I'm just setting it up.
Why should I use DigitalOcean over like AWS or GCP?
Woo! Woo! Oh.
Not meant to be spicy.
But remember, we're in AWS.
I don't like the AWS docs. I've tried to use AWS, like I'm a DevRel person. I make a lot of dev. But I just.
Right. Next to my friend Sarah. They did come out in a bit of a force today. Who among here is from Cerebrus?
Those cuties right there.
The Cerebrus gang. And they have a booth outside in case you want to talk to them. And they recently did a very awesome deal with OpenAI, which I think they, what's the details of those deals?
You can check Wall Street Journal.
Okay, cool. Anyway, so I think that's like really nice validation of the stuff that we've been saying this whole time. And Sarah, okay.
Okay, where's the cord?
What else? Does anyone have questions, thoughts, things to shout out? Okay,
Cool.
I think we are good. And
Okay.
the last thing I'll have you do is show the video. Do this. Okay, all set.
Cool.
2026, the year of latency death. So hi everyone, my name is Sarah Chang. I lead the DevX team at Cerebrus, and we're building the world's largest and fastest AI processor. So you can run inference workloads on Cerebrus 15 to 20 times faster than you can on NVIDIA GPUs. You might have seen me, I post on Twitter quite a lot for work and for personal, and I also help run the Cafe Compute series in San Francisco. So before we get started talking about everything that's broken, I'd like to talk about everything that's been going right in the AI community. So first off, the models are getting bigger. So in the last 8 years, you might have seen, we've gone from models that are smaller than 1 billion parameters to over 1 trillion parameters in recent years. In addition to models getting bigger, we've seen context lengths explode. So if you want, you can pass up to 10 million tokens into your prompt. And as you can imagine, people are taking good advantage of that. So this was a study that OpenRouter released about a month ago, where they sampled 100 trillion tokens of real-world usage across different use cases across time. And so you can see here that in the last year alone, context or input token lengths have increased by 4 times. And as people are shifting their workloads, doing more coding, they're shoving in their code bases, shoving in examples, we can see these input token lengths explode. On the flip side of that, output token lengths are also getting bigger. So from the same study in the last year, output token lengths have similarly tripled in this last year. There's test time compute, there's reasoning tokens, and we can see that out of all of the output tokens, we went in this last year from less than 10% of output tokens being reasoning tokens to over 50% of tokens being reasoning tokens. And so these reasoning tokens are the intermediate thinking tokens that our model is outputting as it does step-by-step thinking before it outputs its final answer. And we see this complemented nicely by all the wonderful reasoning models that the model labs have been giving us in this last year. So the models are getting bigger, context lengths are getting bigger, we can give our models more information, and we have test time compute. And if everything goes accordingly, then aren't we just perfect? And some might even say that AGI has already arrived. So let's do a quick demo, and let's see what these state-of-the-art models look like in practice. This is the most advanced, most brilliant technology that humans have ever created and built. And let's see what happens when we give Opus 4.5 a very simple prompt, asking it to build a simple 8-ball demo. Passing it one prompt, we're vibe coding, let's see it, let's wait until it responds to us.
You block this text. Take it back. It's fine, but you don't need to see it first.
We're just waiting for the model. Opus 4.5.
Don't do this.
I know Six isn't going to invite me back. You bored? No, this is Opus 4.5. TPU. I'll wait. Hmm? You getting bored? Oh, no, it's not ready yet. It's still going. Give him a little more time.
Come on, Opus.
Come on, Opus. Okay, I'm bored. It seems like you guys are bored too. So if you guys have been playing around with LLMs recently, you've probably had a pretty similar experience. And as it turns out that all this exciting innovation of bigger models and smarter models has a very unexciting side effect, namely latency debt. So latency debt is the hidden cost we accumulate while optimizing our models faster than our infrastructure. So when our models are getting bigger and smarter and we're giving it more tokens and we want more tokens out of it, our infrastructure has stayed the same. And even though our workloads have been shifting pretty dramatically. But luckily, a lot of our top labs and top companies have already been eyeing this missing piece. And so if we look at what's been happening in the last few months, we can see that a lot of our top companies have already been investing billions in this latency debt. So a few months ago, we're going to go through a couple case studies about what's been happening. Google released their Ironwood TPU, a chip 4 times faster than four times faster than NVIDIA's GPU. And this is coming from Google, who was and still is one of NVIDIA's largest customers. At the same time, we see Anthropic purchasing over $10 billion worth of Google's TPUs. 2 weeks ago, we saw NVIDIA absolutely gut Grok for all of their IP and top talent. And Grok was building the LPU, their approach to a faster inference solution. And last but not least, most excitingly, and we're not biased at all, OpenAI purchased over $10 billion worth of inference and compute from Cerebras. And so at Cerebras, we have our own approach to hardware. We have a much bigger chip that has significantly more on-chip memory, significantly more cores, and has a very different approach to hardware that overcomes some of the memory bandwidth bottlenecks that we have with the NVIDIA GPU. And so now let's look at what a state-of-the-art model looks like on state-of-the-art AI-optimized hardware. So here we're going to run the exact same prompt that we gave earlier, Opus 4.5, and this time it's running on Cerebras. So once again, we are asking it to create an interactive 2-player pool game in a single HTML file, and this is running on Cerebras. And so earlier we had Opus 4.5, well, it's done already. So earlier we had Opus 4.5 at 84 tokens per second, and that was over 1,500 tokens per second. So as a final note, I want us to take a look down history lane, because history always repeats itself. And so there is a solution to this latency debt that we're seeing. And so in 1985, we saw our first major shift, our first paradigm, when we went from custom hardware to CPUs. And this is when we saw our workloads change. So we went from weather simulations and simple math calculations to now needing programmable, generalizable solutions. So we switched to the CPU. In 2003, we saw another shift from the CPU to the CPU to the GPU, because once again, we had new workloads. Now we had workloads like machine learning, graphics, motion graphics. And so we came up with the GPU. And once again, we're at the third next paradigm, 2026, where once again, our workloads are changing. Now we have multi-agent systems. We have real-time human-in-the-loop interactions. And we need sub-second latencies if we're going to keep up with what our models are demanding. And so 2026 is going to be the year that we abandon our old GPU design and move on to newer designs and newer approaches to hardware that's optimized for AI, like the Cerebras wafer scale engine. And that is it. So thank you guys for listening to the talk. This is my first talk, so thank you guys for listening. You can get started for free. Reach out to me or Junwei and Sarah. And I do want to say a huge shout out to my team, Junwei, Sarah, as well as Haley, for their contributions on this talk as well. Thank you. And if you have any questions, we have a booth. You can come up to us after.
Video on. Okay, you're good. Oh, and then try to make it as big as you can with text.
So right now we mostly serve.
Since are you live coding? Do you need me to hold it for you or? Okay. Oh, no. Yeah, no. You gotta hold it. Yeah, I'll do a talk. And you can go ahead and use the button.
So you can't actually experiment.
Exactly, you have to keep moving. But you can obviously catch your questions after. Okay, next up is Eric from CodeRabbit. Or I don't know if you're here in a personal capacity.
Yeah, more or less. Well, I'm wearing the jacket, so also a base 10 shirt. So not yeah.
Base 10.
Yeah. Okay, let me restart. I'm Eric. Hi. I work at CodeRabbit. I work on developer experience there and our open source stuff, events, some product engineering, things like that. But basically, I'm not going to talk about CodeRabbit. I'm going to talk about this little thing that I built the other week that it was really fun. So I think I got ahead of myself and like just started on this crazy one here. But let me start here. So I call this Claude Code for local small models, a practical little exploration. Oh yeah, and if you want to follow me, you can't see it at all because the Zoom thing's in the way. But at ES on X.
It's on the Lumen.
Okay, cool. So I had like two principles when I came into like building this thing. I basically wanted to build like something that doesn't have to use like huge models and can go really, really fast. But that still that outperforms like those small models on their own if you let them be agentic on their own. So this is kind of what I call like starting from opposite ends. So how many here have like done AI engineering for like the last year or more or something like that? Yeah, okay. So like kind of one of the principles is like when you're building like a system is like use the best model you possibly can to see if you can do the thing that you want to do for your product or whatever your goal is, and then start optimizing. But what I want to do is like flip that on its head and go the other way. What if I use like really, really small models? Like how would the architecture change? And then anyone here heard of Nematron 3 Nano? Yeah. Okay. So this is a model from NVIDIA, came out a few months ago. And it's a really interesting one for using for agentic stuff because it's small. So it's 30 billion parameters. I can run it on my Mac. It's a mixture of experts. So like only, I think it was like two or 3 billion parameters are activated at any given time. And then, and importantly for this, it's trained on tool calling and instruction following. So it's like you can build agents with it. And then the other thing was, maybe this is the only thing I'll actually say about CodeRabbit. It's something I learned at CodeRabbit is that basically determinism and static tools for grounding, for verifying, for accelerating any agent at runtime are better than agentic orchestration. And what I mean by this is that a lot of times you start maybe with like a deep research kind of architecture or like an orchestrator architecture or something like that, and you have an agent kind of at the top. And so you're like your entry point into this system, this interaction is like talking to an agent that's then going to be like, oh, okay, I know how to solve this with the tools that I have. Some tools are going to be like spinning up sub-agents, et cetera. And instead, if you start with like determinism and grounding and via static tools and whatnot, you can actually do a better job. So without further ado, let me see if I can, let me show you this first one here. This is, okay, now I'm going to put the mic down for a second. Is that big enough? Should I make it bigger?
As big as you can.
As big as I can? All right. So let me just start this over so you can see.
You can move that, by the way.
How do I move that?
Just click and drag.
Like that?
Yeah.
Okay. Let me click it over here.
There you go. Perfect.
Cool. Okay, so I'm just gonna start this guy up. And so now I'm in this little CLI. So the CLI, like the way it's built is a lot of different static tools and only static tools as entry points to things. So let's do like, tell me what this code base is about. I need to build a new feature. And I don't know anything. So while this running, we'll come back to that one. Here's it running, and you can see like I've given it a few like really important tools. One, it can run any bash command that it wants, which I'm saying that out loud and like panicking also because you know any bash command. It can like read files and then through that, like I'm giving it some tools that will help it like parse that. And then, again, it's like a very small model, so like I have to optimize those tools for like the size of this model to be able to like pre-chunk and evaluate so that it doesn't take shortcuts and gets the truth and is grounded in that. And then yeah, so you can see it's just like running a bunch of different things. And then it comes back with a not really nicely formatted markdown that's just raw markdown. And this one it elucidated on like a tool. It's fine. And it gives me like a good explanation of like what this code base does. And it's gone and explored it all. This is it exploring its own code base. So let's see what happened over here. It's still running, it's still reading stuff. Let me show another one. Okay, so this is where like I'm exploring a bit more into like what I could do here. And so now I've built in an ability for it to like call different sub agents and also like have sessions and things like that for each agent so that it can reference those back again. But yeah, this one now it can, you could see here, I have like explore, research, plan, execute, refactor, assess, verify. Those are all different like sub agents, all with static tools and grounding. And yeah, it can go and tell me the thing. So like I don't want to take up too much time. But let's see, here we go. So like what I'm thinking of like building in next for this thing, because it's pretty fun to like build with, is one, like all these features have it build it for itself in its own code base. So because it can like rewrite its own code base, it can build the features and hopefully not get lost in rewriting its own self. But I also want to make the UI prettier, like that markdown not rendering bothers me a lot. And then the cloud model support and yeah, different things. I don't know if this is interesting for anybody else, but like the initial one, like the first one that I ran there, that was the at the like the Git stage from like 1 hour or 2 hours of like messing around one night. Maybe it was like 4 or 5, I don't know. But yeah, it was like very fast to build something like this. Yeah, I think that's it. I don't know if there's time for any questions or anything, but yeah.
We do questions with Session with Moin. Moin, are you here? Yeah. So thank you, and then let's take questions while he sits up.
really like out of control, where it's doing things that it shouldn't be, especially with like small models. So yeah, it's basically like giving it like a very specific task with then controlling the permissions that it has and the scope that it has and like what it can know.
So you break it down in like the prompt that it's going with and just give the twist rate of like options to fill the parameter.
Yeah, more or less. And then like one of the things that I should have put on that list is like I want to have a better like programmatic control over like where it is within the code base. But yeah, using like AST or stuff like that. Yep.
Hey, thanks so much, Eric. Fun fact. Eric is currently the leading candidate to run AI in general Hawaii. So if you want to go to Hawaii for work, peer pressure him into doing it. Okay. Next up is Moin, who is doing some really cool stuff with voice AI.
Hey everyone, my name is Moin, co-founder here at Phonic. Phonic is a voice AI infrastructure company, but in particular, we're designed for people who want voice AI scalability, right? So for instance, if you are getting started with voice AI, you might want to start on like a retail or a brand. But the moment you're actually serious and you design a voice AI agent that's reliable at scale, Phonic's the right fit. And I'll tell you why, and I'll give you my predictions on that. So in general, let's think about a voice agent, right? You might call, it might be a customer support query, right? I'm having trouble with my router. You want the ability to understand numbers and digits and be able to pronounce those well. Or you might want to talk about healthcare stuff, right? Like, hey, I'm calling to check patient eligibility and verification. Or you might want to talk about trucking logistics, which is a massive industry that uses voice AI. And the way these voice AI stacks are built today is you start with like a voice activity detection model, right? And what this model is doing is it's basically checking if someone's speaking. When someone finishes speaking, it starts off a whole pipeline. It calls a speech-to-text model. It calls an LLM. It calls a text-to-speech model after that. And these models are fundamentally not talking to each other, right? And when you have these models not talking to each other, you're kind of talking like a patchwork framework. Think about what the models were like before, think about what the agentic, the text agent models were like before Claude tuned them for agentic tasks, before people trained them for agentic tasks. Voice AI is left behind. Voice AI is kind of in where the text models were in 2023. And this is kind of my prediction. My prediction for 2026 is that this stack is completely going to fall away. I think that voice speech stack will centralize around speech models that fundamentally use it. I'm not alone in this prediction. If you guys know Sierra, Brett Taylor from Sierra has actually made a similar prediction, and he strongly agrees that these speech-to-speech models need to be able to reason. And fundamentally, just like we saw with Claude Code, just like we saw with Cursor Composer, this agent voice model co-design is real, right? And I think none of the voice agent companies are doing this other than Phonic. Let me tell you how we do it. So fundamentally, what we're building starts with a model, right? It's a highly performant model built for actual conversation. And this is important, right? Because everyone else is doing text-to-speech. Here's my text, just give me audio. But in a conversation, you care about responding to the way that someone responded to you. If someone says, I'm really frustrated, you don't want to be like, oh, that's great, right? You want to be like, oh my God, I'm so sorry. And you want to have that tone and intonation, the response to their tone and intonation, because that's what humans do. But no one wants to buy a model, right? Like no one wants to buy that forward pass over tokens. So we take that model and we wrap it in a runtime. This is a proprietary runtime built for low latency as a first-class citizen. We do things like torch.compile. We do things like write our own CUDA kernels. We do things like actually design the API and SDK so that way users actually have an SDK they can work with. But then we take that runtime and we wrap it in an agent layer. Now you can connect your function calls. You can connect to Salesforce and Zendesk because you might want to file a Zendesk ticket at the end of the call, right? And then finally, you get the observability where we can now store all of your conversations. And this is pretty important for any enterprise user. But then we also give you integrations, right? In a click of a button, you can now integrate into Salesforce and Zendesk. Let's talk about the model because I think that's the fun part. And I think that's the unique part that's actually differentiated. So there's this question of like, how do you build a model around one, right? In text, you have tokens. Text have tokens, right? A word has an ending and a beginning. Audio doesn't have an ending and a beginning, right? It just starts and it stops at a certain place. So autoaggressive transformers want discrete tokens. Some people will tell you that, oh, you should actually build something for the continuous regime. I don't think that's true. The fun thing with audio is, if you think about it, there's a sample rate, right? Like 44,000 samples per second. Thing is, once you have that many samples per second, you're talking about a highly redundant input. You can actually compress a whole bunch of this stuff down. So basically what we do is we take the audio and we map it into an encoder and get a latent, and then we take the decoder and map that back into a waveform. And then we can basically quantize the latent into a set of tokens, where now we have the first, for a single, let's say, second of audio, we can now map that into 16 tokens. So now every single audio is getting mapped into 16 tokens, and we just predict the actual audio tokens in and out. Cool. Now, the fun part is the audio model is actually trained on both audio and text. This is important because if you train on just audio, you only understand audio. But sound you get both. So for instance, you can take speaker one and then text for speaker one. You can take the audio for speaker two and then text for speaker two. And now the model can condition all this at once. And this lets us scale up to massive amounts of data. We can scrape the internet for audio. We can train on all of that audio. And we can get faster efficiency, compute efficiency, and audio quality. The important other thing is that audio, you probably want low latency. So you can do low latency by writing a kernel, you could invest in architecture, but why? You could use Cerebras. But you don't like all of that any of those. You just fundamentally, if you're going to forward pass with like 10 tokens, why don't you just forward pass over 2 and then get the audio out, right? Like if you can design your model such that you can start generating audio as quickly as possible, that's way better than spending your time writing a kernel or even this use complicated stuff, right? I think simplicity is king. And this also lets you generalize to a conversation. Now you can input as many tokens from previous turns as possible, and we can generalize to an actual conversation. And again, this is what you get when you get a stack that's built for audio, rather than someone patchworking this monkey patch stack for audio. So let's talk about how good it is, right? Here, there's 2 ways to evaluate audio. One is voice quality. Voice quality benchmarks are a little saturated, but in all those benchmarks, we're pretty competitive, right? Here's Phonic against Orpheus, Augmented, Artesia. We're competitive on both word error rate and a stylistic benchmark. I think the more fun one is actually just a head-to-head eval, right? Raise your hand if you know all of them yet. Woo! Should be everyone. I think the real eval is here's audio from speaker A or model A, here's audio from model B. Which one do you prefer? So we work with this company called Codernos, which is basically the LM arena for audio. And we just gave it audio from us and 11 Labs. And we're fortunate to say that we win 46 plus 20, about what is that, 66% of the time, versus 11 Labs wins the rest. And if you look at some of these samples, right, let me play a sample for you from us and 11 Labs. This is Phonic. Oh, is the audio working? Well, I'll play it from my laptop.
Selector -B2 and mess around.
So here's us.
I was scrolling last night and randomly ended up at www.artbygen.org/gallery/personal/favorites, and her sketches totally reminded me of your style.
And here's 11 Labs.
I was scrolling last night and randomly ended up at www.artbygen.org/gallery/personal favorites, and her sketches totally reminded me of your style.
So I got a couple of others. Phonic.
So yeah, just head to tools.gadgethut.com/sim-selector-B2 and mess around with the settings.
And here's 11 Labs.
So yeah, just head to tools.gadgethut.com, tools, sim, selector, v2, and mess around with the settings.
So you can see, especially for our best voices, users prefer Phonic over 80% of the time. Now, just building this isn't enough, right? You need an efficient runtime. We do all the fun stuff like speculative decoding, quantization, et cetera, to get these efficient. We also give you an SDK. So if you want to launch like an outbound call to a phone number, all you have to do is hit one endpoint and you get that. Here's what it looks like to use Phonic, right? You get a nice UI, you can type in a system prompt, you get access to tools, et cetera, et cetera. It's all quite simple to use. You can look at a single conversation, you can see all the individual turns. We show things like tool calls in the UI. If anyone uses Claude Code, you get access to abstractions like a task list, where rather than having to detail all the steps you need to do during the phone call, you can just write it in the task list and the model will check off and cross off tasks during the conversation, kind of like a human would in a call center, right? And then you can also get access to tools, either via WebSockets or webhooks, and the model can then call those tools during the conversation. Again, just like any other type of agent would. You can see all of your previous conversations. And most importantly, personally, when working with customers, I felt like people are just playing prompt whack-a-mole, right? You try and fix the prompt for one use case, and then all of a sudden another conversation fails. So Phonic actually improves the agents via RL. You can click on a single turn, you can say like, this was transcribed incorrectly. And then we take that data and we do feedback on that data, right? Similarly, you can take a turn and you can say, this was missing a tool call, or this was unnatural. And Phonic uses that as preference data to improve your actual voice agent. This is the only voice agent platform that actually improves on your data. Let me give you a quick demo. So here's a sample conversation.
Hey there, how can I help you?
Yeah, I'm actually really frustrated right now. I've been waiting 3 days for a critical shipment. I still haven't gotten an update.
I'm really sorry you're going through this. Can you give me your shipment ID so I can check what's going on?
Yeah, it's ST91247B.
Thanks for sharing that. Just to make sure, that's ST91247B, right?
Yeah, that's right.
All right, thanks. Give me just a sec while I pull up your shipment details. Okay, I've got it. Your shipment left the Oakland facility yesterday and it's now in Los Angeles, scanned at the local hub. It's scheduled for delivery tomorrow before noon.
Wait, are you sure it's tomorrow? I mean, I was told that 2 days ago too.
Yeah, that's a fair concern. This time I double checked it's actually scanned at the local hub, so it's definitely in LA and set for tomorrow before noon.
Is there a tracking number associated with that?
Yep, the tracking number is 235-98325. Would you like me to send it?
I didn't quite get that. Could you say that back slower?
Sure, it's 23598325. Want me to email you a tracking link too?
Yeah, that would be great. My email is nikhil@phonic.co.
All right, I've sent the tracking link to your email, nikhil@phonic.co. Please let me know if there's anything else I can do. Your patience has meant a lot here.
Yeah, no, actually, thank you so much. You've been really helpful. I mean, if it actually does show up tomorrow, I owe you a thank you email.
Deal. I'll be on the lookout for that thank you email. I really hope your shipment shows up as promised tomorrow.
Yeah, no, thank you again. Have a good day.
You too. Thanks for hanging in there. Take care.
Perfect. So if you're interested, we're in production with customer support companies like Sierra, Decavon, and Maven. We're in production with healthcare companies like Soap Health. And we're currently, the entire company is scaling quite well. We just wrapped up raising over $30 million. If you're looking for a job, on hiring for both intern and full-timers. Feel free to drop your LinkedIn and enter a raffle for a resume as well. Thanks, everyone.
Okay, yes. Well, then we'll ask questions. Before we get to Q&A, Karthik, are you here? Karthik, okay, awesome. Karthik's going to talk about video models. We're going to set him up, and you can disconnect. In the meantime, we'll take questions. Who's got questions? Yeah, go ahead. Shout it out. Thanks for speaking.
Yeah, very good question. So, just to repeat the question was broadly speaking, where are you getting your data from? We have stages of training. So we start off by just pre-training on conversations. Just imagine any video on the internet is fair game or any audio on the internet. Then from there, we go into conversations. So generally speaking, speaker A, speaker B, speaker C. And then from there, we have preference data. Either users have their own preference data, but generally speaking, we'll show users 2 generations and they choose one of the 2. So that way we can do reinforcement learning on that. That I can't say. I can say we are one of Cloudflare's biggest customers on storytelling. Go ahead.
How long do you think this idea of like transforming the voice tokens to write with other questions and scale so rather than
Ooh, good question. I think it actually, we were surprised at how well it worked. I think it'll work better than anyone expects. Oh, the question was how well will scale going from like text to audio tokens map to other domains, for instance, text to image tokens. And I think for us, the transfer was actually quite easy. I suspect it'll be easy in other regimes as well. Go ahead.
Do you have any custom in-house guided basic models or some of the pre-processing models that you plan to open source?
Yeah. Ooh, good question. Not that we plan to open source. The question was if we have any diarization models that we plan to open source, any custom pre-processing models. Go ahead.
How much harder is it?
Ooh. Yeah. We post-train on those tasks. You can imagine for an enterprise, it's pretty useful. No one wants to call a customer support company and have it leak information. So we have to do post-training on those tasks for sure. The question was how much do we have to, how is it more susceptible to jailbreaking because it's audio models? Go ahead. Was the question around backend noise? Yes. Yeah, this one's hard. So the question is around how this reacts to background noise and like especially noisy scenarios. It was a problem in the early days. When we went into production with the first customers, this was a problem. We started time training models that are more robust to this. And that's our is we have a data set that has a lot of background noise compared to others. It doesn't prior to taking a production. So as a result, we spent the time and the effort to get good at this. It wasn't perfect. Any other questions?
From English, is there another language that focus?
Yeah, definitely. So the question was aside from English, what other languages do you support? The fun thing with the model is the fun thing with the model is polyglot. So in one conversation, it can actually switch from English to Spanish to Arabic and others. We have set voices that support the gamut of languages. It's pretty cool to see this in production because someone will call customer support. They'll be like, "Hi, how can I help you?" And I'll go like, "Apologies, my Spanish isn't very good." They'll go like, "How did I miss?" And the model will immediately switch you to another language. It's a little futuristic to see one model switch across languages like that. Perfect.
You guys all have thanks to the
So one of the leads to the future of speech-to-speech models, we actually have someone who will definitely disagree, who's the CTO of Hycat over there, which releasing pipeline. So you can stage the debate between the two of them. If you want to, wait. People want to talk to Hycat. Okay, cool. Karthik is going to talk about video models, which also I think this year is going to kick off in a very meaningful way.
Hi everyone, I'm Karthik. I'm a senior AI researcher at Tavis. So Tavis is a company which is like a research company which builds generative AI models, basically human replicas. So what I mean by that is like we can build real-time replicas which looks like you, talk like you, and they speak like you. So instead of you joining in calls, your replica can join in calls and can speak on behalf of you. Yeah, like I prepared for the talk in a different way. Like first, let's go to some of the technical stuff, and then we can go through the demo of like the product.
Share your screen. Yeah, exactly.
Okay. Yeah. So the range this year is all about diffusion models, right? So why is it? So there are like multiple kinds of models which are there before, like nerve models, Gaussian splatting models, and now it's diffusion models. It's because like diffusion, models like nerves, Gaussian splatting are more like reconstructive in nature. So what I mean by that is like you need to give like different views of yourself in 3D and based on some like input context to generate the output. Whereas the diffusion models are totally generative in nature. So what they do is like they build like deep structural understanding of like a lot of videos in your data, and they build like close relationship between like the textual prompts and the videos, and it's very easy to scale those models. It's just the way it is built, and also they work across like multiple steps. So they do something called like flow matching or like diffusion matching and stuff like that, where it follows a path from noise to data through multiple steps, and it gives it's the strength to sort of like render some awesome stuff. But the issue with it is like, can we generate like long videos, and at the same time like can we make it like auto-aggressive and fast? So just like 1 year back, it took like more than 1 minute to like generate like 2 FPS and stuff like that, and we have come like a long way from that. So why it is? It's because something called like error propagation, where you can see here. So you first start with like good frames as like a ground truth, but as the error propagates through the video and you generate like next frames, there are artifacts there. So this talk is just some of the techniques which we use to sort of like overcome these artifacts, and then we can see the demo of like how we use it in Tavis. Okay, so there's something called diffusion closing, where it's like instead of giving like uniform noise across like all the frames, if you give like random noise across the frames, what's happening is like the model at the training time will understand, okay, so if the previous was in like different noise settings and then the next thing is in different noise settings, um, like what to do. So it will see like a lot of reactions like this. So let's say, so even the inference time, when you sort of like have a thing where the error gets propagated, but since it has seen like variable noise throughout its training procedures, since you gave like multiple noise levels during your training, so the model will know how to react and be able to like fix itself. So that's like one of the techniques. So to make it faster, there are like multiple techniques which we use. One is like distillation matching, and also like going from like bidirectional into like causal models. Because like during training, you will have access to the entire stream. But during inference, let's say I speak, and depending on what I speak, I need to render my frame. I can only have the past frames, right? I don't have the ability to look at the future frames. So basically, like how would you render the videos with just like, the past frames? So that's like one of the techniques. Okay, so basically, this slide is about like one such technique. So what I do is, you use a generator model to generate this stuff, and then you have like two different models here, which are like locked, basically with like no grad. So you get the image. So basically, what you do here is this gradient is something called scoring function. It basically tells you in which direction to go if you want to like correct the gradients. And when you like multiply it with the source image which you generate here and do the back propagation, so basically the model will get like a residual connection from here to here, and will be able to like understand like what to do. Yeah. And this is like one paper also, which is like, let's say you have like multiple noise levels, and you need to do in a autoregressive manner. So when training the frames, you can look at the past frames and future frames, but during inference, you can only look at uh, the frames which are in past. So this paper talks about that. So basically, what they do is they first do something called like division posting, which is on the first paper, where they split into chunks, and each chunks will have like different noise levels, and then you give it into like a transformer, which is like take the past frames and like do self protection and produce the next frames. So just like combining transformers with division models. And now there's something called like self forcing, where it is like in the past we see during training you have like ground truth and use the ground truth to train. So, but what happens if you sort of like instead of using the ground truths, you generate the frames and use those frames to train itself. So it may sound simple, but there are like few tricks here. It's like if you don't like detach these few things, like when you use this frame to like generate these frames, a lot of backprops accumulate, because like just to generate this frame, it will take like around like 10 steps. So if you like multiply across steps, it will like become like increasing. So they do something like this, where they only pick like steps which you want to do, and then like they drop the gradients. And for the next things, they just like use it to like generate the frames. And this is like one more technique where rope is one of the techniques which is used in LLMs. So basically, if you need like variable length, you need to understand where the frame is there. The same concept is like getting applied to the video models too. And we basically use the technique to sort of like understand the information between like, okay, this frame is before this frame. So like understand those semantics and like give like better better strength to the recent frames than like the frames which are like very far in the future or very far in the past. Okay, now let's try out like a product, right? Basically, yes. So this is like one of the replicas. They it is trained on like real humans. They look like you and they talk like you, and they can even like see me. Hey, can you hear me?
Yeah, I hear you loud and clear. Okay, so the seeing me part, that is actually wild technology. It's like having a conversation where the person actually gets your vibe and your reactions, not just your words. It changes the whole dynamic, right? Like it actually feels.
Hey, I have a question for you. Can you see what I'm wearing?
Okay, wait, yes, actually, I can totally see you. You've got that olive green jacket on, and I clocked the AWS Builder Loft lanyard too. Are you at some kind of tech event right now, or is that just your everyday aesthetic?
It's just how I look every day.
Okay.
So basically, there's
We're
like,
just hanging out.
1 second.
No rush. Take your time. I'll be right here.
So basically, there's like a bunch of things in play here. There's like perception model, which sort of like understands what I'm doing in real time. There's like a turn-taking model, which dynamically knows when it should speak and when I should speak. So basically, if I speak and if it like starts speaking immediately, then it won't look natural, right? So there's like latency to understand like when to speak. And there's like rendering models, like a division models there, which like renders the screen. So basically, we conditioning it on the text and audios to like render the frames. And there's like a lip syncing model, which is like producing like extremely good lip syncing and stuff like that. And that was one of the like leading companies, or like say SOTA in like real time video models. I don't think like any other company can match what Tao is doing in like real time stuff. I think we can continue a bit more. Like, can I speak to a bit more? Hey, can you tell me something about some TV shows which you recently watched?
Oh, absolutely. Okay, so I just finished this limited series that totally blew my mind. It's called Baby Reindeer. I know the title sounds weird, right? But trust me on this. It is a masterclass in tension and unreliable narration. The way it's shot.
Okay, 1 second. Do you know anything about tennis or like pickleball?
Oh, tennis and pickleball. Okay, I have thoughts. Tennis is classic drama, right? It's like the original reality TV with rackets.
Oh, no. I meant the sport.
Oh, okay, I gotcha. So you're strictly interested in the mechanics and the game itself? I can respect that. Here's the breakdown. Tennis is all about that solo or duo intensity. It's precision, power, and covering that massive court.
Okay, got it. 1 second. And
take your time.
Also,
I'm
like,
here whenever you're ready.
Have, like, agentic features. There are some replicas which you have which can email you, which can message you and stuff like that too. Yeah, so that's why like I think this year is going to be the year of video models.
So yeah, there's a lot of work.
Replica is going forward. Okay.
Okay, yeah, can you shout it out?
No, I talk to her every day, so that. Okay, I think that's all the time we have. Thank you so much.
Yeah, go for it. Okay. Yeah, that Tabas demo was super cool. I've been following along for like 3-4 years. That's amazing how much progress they've made. Okay, I want to start out with a question. How many of you guys use Claude Code on your laptop? Okay, a lot of you guys. Can put your hands down. Okay, you're all cooked. This is here's my hot take, okay? Laptops won't be where programming happens for much longer, okay? I think they'll still exist, but they will be interfaces. They won't be where you do your workspaces. And the first reason for this is agents can run 24/7, okay? Humans cannot, right? Agents can do the triage, and they can proactively address things, and they can run CI. And so tying an agent to an ephemeral machine, it's just architecturally flawed. It's ridiculous. And I mean, because essentially we built these agents that can never sleep, and now we're tying them to machines that do, right? So the first reason why I believe agents should be asynchronous and cloud ready is, simply because, like, if you've seen 12-factor agents, like, agents need to run in a continuous persistent loop, okay? And if your agent is bottlenecked by your laptop being on, then you're severely bottlenecked, like you can't do that. The second reason that I believe this is because your agent should be accessible anywhere. Like, your agent's corresponding code base, you should be able to use it on your laptop, on your phone, on your tablet. And if your laptop is closed, there's no good reason that you shouldn't still be able to access your agent and its code base, okay? From another device, right? So now the natural next question is, why now, right? We've always had the cloud, and why is this particularly relevant today? And the reason for that is, before agents, this didn't even make sense, okay? And that was because the only person that could write code was you. And so it made sense that your code lived on your machine, okay? But agents have changed that in one step, and it hasn't been like a gradual thing. This is a step function. This is a big jump that's happening. I like to think of this as like a simple timeline here. So I have a timeline, and stage one is we had these local first coding agents. So a lot of you guys mentioned you use Claude Code, for example. We have these CLIs, and these agents, they die when you close your laptop, okay? Stage two came pretty fast. We got Replit and Lovable, and basically all these vibe coding tools that are completely cloud native, that they run completely in the cloud. And a lot of developers I talk to, look at this as toys, right? These solutions. I think Polygram has a really good essay about this, but every core workflow that gets replaced initially starts out as a toy, because early developers or early adopters are willing to deal with the friction of using it. But anyway, the point I'm getting at here is that there's something really overlooked there. And then that brings us to where we are today. So now you're starting to see this, like, we're getting into this transitory phase where you have like cursor background agents, and then you have people like merging those changes back down locally so that they can run their tests or their environments. You have Claude, which has this Claude web teleport, where you can like teleport things like back down locally after you do it in the cloud. You have what we're working on, as well as a whole bunch of startups now, which are cloud sandboxes, so you can migrate your environment to the cloud and migrate it back. And these are messy. Like there's split state here involved. You're trying to the agent state, the agent's context is divided between two different environments, right? And so it's a really hard technical problem. And now you're getting to what I think is an end game. What I predict is going to happen in 2026 is that the agent will just persist in the cloud altogether, right? And that's really important because your device now just becomes an interface for the agent. You have asynchronous supervision is the norm, right? And that reduces a lot of friction. So I made 2 points earlier about persistence and accessibility being like the main benefits to running coding agents in the cloud. But I'm not, to keep it even simpler than that, I'm not saying that if we gave you all cloud sandboxes, that you'd be running cloud code 24/7 in the cloud. I think even simpler than that is the even more immediate win is just you have access to your agent now. So even if you're just going to run it for 10 or 20 minutes, you can use it in the gym in the bed or like wherever you may be. We joke a lot at our company about toilet coding, right? Which is like a step after vibe coding, I think. But yeah, it shouldn't be strictly tied to like when your laptop is open. Is really the point that I'm getting at here. And obviously, we should be practical. There is an adoption blocker here, which is that we're all developers here for years. We've had our local environments that we've set up, and we have our macros and our tooling. And I'm guilty of this too, but I think this is all the more the reason why it's so important that we have the rails to let people be able to move towards this future without friction. Okay. This is personally what I've been working on lately, and I know a lot of companies are, and that's making agent sessions in environments migratable, so you have the same state, the same context, and then you can just move it to where it's running. So in closing, and I'll show you a demo here in a second, but in closing, local and synchronous workflows only made sense when the only thing that could write code was us. Okay. Agents change that in one step. So if you want to be ahead of the curve, do the hard work in 2026, make your dev environment reproducible, make it cloud ready so you can move it to the cloud. And I think the future is really simple here. Your agent will need access to your code base 24/7, even when your laptop is closed. Okay. So with that, I'll show you a little demo about what we're doing at Amnara. This is my Twitter. Feel free to follow me. Yeah, let me just show you guys. Yeah, I didn't want to show it initially. I know there was like no shilling or anything like that, but I'll just give you guys like a high level, just show you guys how Amnara looks like so you get an idea. Yeah, so this is Amnara. It runs as it's an interface on web and mobile and any device for your coding agent. And you can see here, there's a daemon that runs on my local computer, but it can also migrate any of my coding sessions to the cloud as well. So I can just click on any of these. Okay, yeah, I think, yeah, I'm running on a local environment here, but yeah, on amnara.com, if you go there, you can move any of your local coding sessions to the cloud so that you can continue them when your laptop is off. Okay. And then you can access them on your computer, and then anything I ask here will also show up on the mobile app as well. So now you can access Cloud Code on your phone. And yeah, I'm happy to take any questions.
Nice. In the meantime, we'll bring up Jay, I think who's next, and then take questions. Nice work. Thanks. Okay. It's quite too clever.
using something like an interface for programming as opposed to using TMAS, like a stage.
Yeah, like if you just run plot on a remote machine.
Yeah. I think I think the big thing is there's a lot of different things. One thing, I think that is a perfectly viable solution. That's something a lot of people are doing. But if you want to have work trees, you want to have an interface for work tree isolation, you want to be able to access having a good interface to be able to access the agent. We also have other things like a voice interaction that you can do, an orchestrator mode where you can orchestrate multiple agents and see what they're doing. All of those things are a lot more difficult when you're trying to do SSH on your phone. It's kind of like, why do you use Dropbox? You could just FTP a server yourself, right? You know, it's kind of like that. Yep.
What makes you different from like the Claude code? Like I know Anthropic has something which like works on web, and I think you can teleport it.
Yeah, so Claude Code does have Claude Code Web. You do have to, it's good for quick and stateless work because you have to basically connect to GitHub and then you create a cloud environment and then you have to sync that down via teleport locally. We discovered that the problem a lot of developers have is they actually want to go the other way around. They want to go from their local environment to the cloud and then back if they want to come back. And, you know, not to mention all the other things like having work trees and an orchestrator, stuff like that. Yeah.
Okay, cool. We gotta move on, but thank you so much.
Cool, thanks.
Yeah. Yeah, you know, like I always design these things to just be all lightning talks so you can get a hit on like what everyone is working on, and then after that, just Q&A yourself. Last speaker, because our Karan couldn't make it today, is Jay. They also have a booth outside. He also brought some people from the DAF team over there. Yeah. Oh,
spread out,
nice.
yeah.
Okay, cool. And we grouped some of the cloud background agents people together, so this is the second one.
Nice. Yeah, hey everyone. Really excited to give this talk. This is actually probably my first talk that isn't at a data meetup. So this is going to be really exciting. I've had a lot of thoughts about data and AI for a long time. And today I'm going to be talking a little bit about maybe something that seems non-controversial at the start, but I think it actually is background agents. And actually specifically why I think this means that it actually changes the way that agents work with data in general, external data, right? So I want to talk first about what background agents are not, because that makes it a lot more specific and it's not just automatically obvious, oh, like, the background agents, right? So first of all, it's not the foreground agent. I don't think anyone ever says the word foreground agent. This is by default what we mean by agents today. The main difference there is that a foreground agent, like we use Cloud Code, that's hooked into your center inside out. It expects the user to be in the loop, right? It blocks on the user input, and you like work with it every day, right? So that's a foreground agent. Background agent is not that. So what it is it never blocks on user input. It is not just an agent with a long trajectory, right? It's not as if it's not just an async agent. Like if it's an async agent, you let it run in the wild with really long trajectory. It's not just that. I think agents with long trajectories are a requirement for background agents. But you know, the main thing that really defines a background agent is this idea of an infinite context. So it never ends, just like a service, microservice that keeps running all the way. And the last thing is, it's not just many short trajectories, right? You could technically do this with like cron jobs. Yeah, you run a short trajectory every hour, or web app, you run a short trajectory on every endpoint. That's stupid. That's not a background agent. What a background agent is, though, is this idea of like state. The state is persistent across this entire kind of infinite rollout, infinite trajectory. So this, I think, narrows it down very specifically to what a background agent actually is. And then all of a sudden, it's not just automatically like, oh, background agents, right? It's like, okay, like, why do I even need a background agent in the first place? So let's talk a little bit about that. What median enables, right? I put in red this one here, because I think this is kind of dumb. Event-driven workflows, right? People are like, humans are reactive. We don't just, you know, activate when a prompt comes in. You know, I put here, manager says needs improvement, right? Lacks initiative. That's the feedback we give this agent. So now, yeah, with a background agent, maybe your agent can choose when to activate. I think that this is actually a weak argument. The counterpoint, the bitter lesson that I bring from the world of data is almost everything this like event-driven thing can kind of be achieved with a smart use of like webhooks or cron jobs that just wake up from time to time and just run a shorter trajectory. And there isn't this requirement around accumulated state, right? Remember we said before, that background agents are these like long running things that accumulate state over time, infinite context. So I think this is the kind of a weak argument. Some people say that, oh, agents can like listen to file changes. I'm like, you could do that without a background agent. Just use a normal kind of file system watcher thing, right? What it maybe will enable though, I think this is where it starts to get exciting. Number one, we can now cut humans out of the loop, right? Remember I mentioned that foreground agents block on user input. Now you just take the human out, right? I come from the self-driving world as well. Self-driving, we started when you have like over 100 cars in the world running around, and the safety driver sitting right there, right, intervening on the wheel. And then now we're in the over thousands, right? Waymo's running around, and you actually have these async runs happening. Call them background agents. The agent, the agent is the cars running around. And what's actually happening is you have remote operators sitting in the background and monitoring, say, 36 cars at a time, right? And so they are like starting to get out of the loop. When we hit this kind of inflection point with the 1 million plus, call it, is when we have these truly background async runs on the car and no human interventions. And what background agents enable then actually is humans completely go out of the loop, and you can now run millions of these agents without really needing a human to be the bottleneck. So that's really exciting, right? This is the other one. Who's watched this movie? I love this movie. Keep Tom Cruise, except for Top Gun 2. Hot take. Smarter agents over time. There's a lot of talk around like memory, continual learning. But why need memory if agent no die, right? If my agent just lives forever, like I don't need to remember stuff. Just stick it all in the context window, or have the agent itself do context management. Continual learning. If the agent no die, why does it need to keep learning? Just keep it on the context window. Right? I think there's a lot of talk around, can tokens in the context window be where this learning happens rather than you go back to our learning model itself? I think it's a very valid point. And yeah, if you have background agents and all the kind of innovations that this requires, then yes, you actually get this almost for free. Smarter agents over time. Very cool. Agents that learn. And the last one, this is where I get really excited because I've been thinking about this one a lot. It's a little bit unstructured still because my thoughts are still like, synthesizing in my head. But there are two main points I want to make here about knowledge and how knowledge differs from data. The first point I want to make is this idea kind of similar to gas time, where today our knowledge and data, everyone talks about RAG, right? You're like retrieving raw data, and this raw data is in some database, maybe VectorDB, like S3, I don't care, right? It's outside of the context window. But what happens if we just keep all the data in context window? Like crazy idea, but just spawn a million agents and keep everything in context window, right? You have one agent per document, I don't know. But all of a sudden now you actually have kept your data in situ, inside an agent itself, versus needing external retrieval every time. And what this lets you do is instead of relying on retrieval, you're actually relying on synthesis, because your agents are synthesizing this data again and again as they run in the background. Very cool, right? The second part of this argument I think that this enables is, who's been part of this like context graph thing on Twitter? My God, it's like, everyone's favorite bandwagon now. But also I wrote something about like my thoughts here on like knowledge curation, right? I think people in the context graph discussion are starting to now talk about how the useful information, the high signal stuff is not just in the materialization of the data, but in the walking of the data. As you're walking the data, the agent trajectory gives you information about the ontology of the data, right? And I think this is really interesting. I'll get back to this at the end of this talk, where I think there's a lot of high quality data right now in agent traces. And as you run these background agents, there's going to be so much traces that are being emitted, and all the high quality information is actually in the trace, right? And we need systems that can really understand these traces really efficiently to then improve what we do. So two main points here about knowledge. I think we'll see which one pans out this year, but I do think that like the way that agents work with data is going to radically change this year now that we have these autonomous background agents that can run around. Early signs and trends, I think that make me think so. Number one is that agents are now becoming the user, right? You are now the user of Cloud Code, but now actually we're starting to see Cloud Code do a lot of sub-agent delegation. And I said that the user used to be the blocker for these foreground agents, but now you think about it, right? Why do you need a human for standard in? An agent can do it, right? And so now I think this is like the sub-agent delegation, and also really interestingly, this idea of out-of-band context management, right? Where now the agents are taking on the role of what we used to play as the human launching Cloud Code. This is really interesting too. Utilizing capacity more at the time dimension. So this one is a little bit more interesting. There's this paper, Sleep Time Compute by the Letter folks, which talks about, hey, like if you don't utilize your LLMs, right? Sorry, let me rephrase that. As your LLMs are sleeping, there's a lot of useful work that can be done. And the way that they did this is that they basically tried to simulate questions that might be asked at runtime and then try to run it early on while there's nothing happening, right? And also, we've started building internally a lot of tools to look at how Cloud Code is used internally within the company. And it turns out the agent's just waiting for us. Look at this big long gap. Look at this big long gap, right? And there's actually a lot of useful work that should be happening here. You can anticipate stuff that's coming up, right? Anyone who's ever done like CPU design knows you can do things like, run optimistically, right? And then kind of backtrack over time. There's a lot of really cool stuff you could do here if you had access to something like a background agent. And this just unlocks that time dimension because background agents run always, and you're always utilizing compute, and you can always find useful work to do. And the last thing is I want to call out to the async talk that we just did earlier, right? I think that, yeah, agents should not be running on laptops. It's like putting Usain Bolt in like the body of a 10-year-old. It's like, I want to run. I know how to run, but I can't run, damn it, right? And yes, so that's the first step, because once we can put them in the cloud and let them run with their own environment, then you unlock the background agents, which I think is really exciting. So where does that leave us? We're running a little experiment. So I'm here on the Daft team, but no showing of Daft today, because we're actually running a little fun experiment. We call it DGen. Like if you want to be a DGen with us, come DGen.ai. It's a fun little experiment. We're gonna grab all the traces, right? Send us all your traces. We'll ship a little tool. Send me all your Cloud Code traces. And then we're going to make these agents better over time. It's really cool. We've started looking at these traces, and there's so much you can glean just by seeing what Cloud Code is doing. It's like, dude, why are you compacting, bro? Like, why are you calling this tool call? Why are you using UV instead of pip? I told you to use pip. I told you to use, sorry, no pip. I told you to use UV, right? Why are you using pip? And it's really interesting now that we have a lot of expertise in large scale data processing of unstructured data, and we're running a lot of processing over this to derive these insights. And I think we can mine this data and then feed it back to the agents, and we're going to make these agents better over time. So if you want to be part of this, send us your Cloud Code data. So you think you can Cloud Code is the name of the challenge. And then we'll send you some insights to start with over your Cloud Code data. But yeah, QR code, that's the end of my talk, and we'd love to chat more if you have more thoughts about data, agents, stuff.
Couple questions, and then we can break and mingle. Can we let the others speak? Yeah. Shall.
There's a slide on the agents trying to work with rather ability inside the context. Are you essentially saying summary of document, sort of the say you repeat the question.
Yes. So the question was the slide where I talked about, the data not needing to live in a database, right? Just make it live in a context window. What am I actually referring to? I think that's implementation detail, but I'll delve a little bit into what I think about it. So today, data is just raw data, but it hasn't been synthesized. And so the interesting thing, I don't have it on this slide, but if you work on databases, you're always doing this trade-off of work that happens at runtime versus work that happens at indexing time. And if you ever have to optimize a database, what you do is you see all this work that's happening at runtime. Can I then push it down into indexing so that then runtime becomes a lot faster, right? So simple things like joins or lookups, that's what you do. This is actually, if you think about it, an application of that. Because if I have, say, the same question that comes in and again, and I'm always processing the same document, retrieving, and then sticking in context window, and then doing that same processing again and again, it's so wasteful, right? Why don't I do that once by sticking it into an agent context window, and then now I can just start from there, call it a cache, sure. But the idea is really like, can I push the work that my agents are doing again and again at runtime into kind of a more static, like offline process? Yeah. Go ahead.
Question I had.
Yeah. So I have another hot tip that doesn't quite make the slide, that I think training, for some reason, is starting to come into the vernacular for agents instead of models. And I think that's actually a very interesting thing. Right? In the past, you would never say let me train an agent, you say let me train a model. But I think it's actually very viable to think of training an agent today. And the way we train an agent is by giving it new context, right? We train our agents by amending Claude MD. We train our agents by, amending the context window. And so yes, we should totally be training over context, but maybe not in the sense of training the model, but can we actually like feed this back into the agent? I don't think that's really good research around it just yet, but I'm sure that will develop this year now that you just saw into. Yeah. Go for it.
Usually the companies have gigabytes, terabytes of data.
Yeah.
So you just basically store data with it somewhere. That's usually the data.
Yep.
Okay.
Yes, I mean, I think it'll be very dumb to just like put everything in the agents for sure. So you have to be selective, right? But there are so many techniques around this. You can do like cache eviction policy. You can kind of like check what hotspots are happening within. Out of your documents, what we found also is that documents have a very temporal relationship with how they are retrieved. You probably never looked at a document that's 3 years old very much, but the documents are more relevant or more temporally combined. So yeah, I think there's ways to work around it. But also like there's a lot of things you can do. So Hardy, for example, does the thing where they run views on top of these documents, so you don't store the entire document, you store like a view right on the script, the view agent, which is an interesting idea. Oh, 100%. Yes. So I'm not gonna store like an iceberg or Delta Lake table or like anything crazy like that. That'll be crazy. Yeah.
And that's it. Thank you, everyone. So appreciate you all coming. That was it. Really strong ending from FNJ. Everyone's gonna be outside. You can mingle, chat, ask all questions. Thank you for coming. We'll be back next month.
Thanks for having us. That was fun.
Hey.